I give this talk because I've made some mistakes. One of the mistakes I've made recently was actually giving a talk on a podium that had a slanted podium. This happened to me last month. So if I seem a little skittish about the slanty podium here, just bear with me. Anyway, so once upon a time, about 3 years ago, I had a new client. I am a consultant, and I started working on a new client. And this client had an application that was taking in, they were taking in credit card payments for a particular product. I'll be a little bit vague. They wanted to dramatically increase the complexity of their business logic. They were adding a new kind of product to their application, and it had a significant amount of discounts and special features and a lot of logic like that. But because the application was already taking in credit cards and already talking to a gateway, that API part already existed. And I thought that meant the hard part about dealing with money was done. Like, I knew that the business logic was going to be complicated, but I thought, because I was naive, that the hard part about dealing with the financial stuff was largely behind me. Here's a spoiler. The API call is not the hard part about dealing with money. And that's what I'm going to talk about for the next apparently 28 minutes and 8 seconds. My name is Noel Rappin. I work for TableXI, which is a consulting shop in Chicago. If you want to work with really good consultants, or if you want to work with or for a set of really good consultants, you can find me. I'll be here all week. There's a couple of other people in green hoodies, or possibly not in green hoodies, who are here to talk to you. We love this community, and we're always looking for good people. You can also find me on Twitter at Noel Rapp. Say hi. If you have questions about this content that you want to ask me on Twitter, that's great too. I like that there. So a little bit of context on what I mean by the API is not the hard part, and what those APIs do, because those APIs are really, those payment APIs like Stripe or Braintree or Authorize, like, they're really amazing in some respect. Like, this is basically one line of code. I mean, it's like 7 lines of code, but it's basically one command that's calling stripe.charge. And there's some other stuff behind the scenes here that's giving me an authorized credit card number effectively. But this basically very small amount of code is going out into the real world, and it is going to transfer $10 from somebody else's credit card to my account. And this is basically all I need to do to have this happen. And that is amazing. I looked into what actually happens behind the scenes when you do this. And I still am not completely sure I understand it, but it usually involves at least 5 financial institutions behind the scenes. There's the buyer's bank, the bank that issued the buyer's credit card. There's Visa or MasterCard or whoever runs the credit card network, the merchant's credit card authorizer, and the merchant's final bank. Forgetting whoever owns whatever transfer lines come in. It's incredibly complicated. And it happens in an instant, and it happens something like 1 million times a minute around the world. But that's not even the hard part from our perspective, because we have these fantastic APIs that cover all of this complexity for us, or a significant amount of this complexity for us. The complexity in our applications come after that. Our complexity comes sometimes from unexpected places. Sometimes they come from line of code like this. This is a hopefully innocuous looking line of code. It's a Rails validation. It is validating a last for, an attribute called last for. And if you can't make the regular expression out on site, if you can't sight read the regular expression, I can't. This is 12 capital X's followed by 4 digits. Who here is chuckling ruefully because they kind of know where I'm going with this? OK. So this was this was code that was written as part of our application. And so to put this in place, there's a common pattern when you're dealing with a credit card transaction. You save some data. The user fills out a shopping cart or whatever they're doing. They fill out an order, and you hold on to that data locally. You go off and charge the card. And then you have to take that card response, and you still need to do something with it, even if that is just put it in your database to get processed by somebody else. Okay? You can't just let that response fall on the floor and not do anything with it. And that leads to two hard-to-deal-with failure scenarios. The first one is where the charge fails, but you still power forward and save it as a completed transaction. And in that case, you've given the customer something for free, and if it happens often enough, you will have an angry manager. Or you may have no manager if it happens often enough. Yeah, these are the kinds of things that terrified me once I started working in financial applications. Or, and this can go the other way too, the charge can succeed, but the save can fail. Something can fail in your process afterward, and now you've taken somebody's money, and potentially you have no record of that fact. And they're not getting the service, and you haven't even recorded the fact that the transaction took place, so now you have an angry customer. And again, if it happens often enough, you don't have a customer at all. So, back to this. This line of code was in our, we were saving the response from our payment gateway, at least some of it, as part of our post-processing. To some extent, this is good practice. We are holding on to some information that is somewhat hard for us to get by other means. And we thought, well, they send us the last 4 digits, and they send it to us in this format, so let's validate for it. Except that about like 1 in every 200 or 300 transactions, they didn't. There was some sort of glitch between either the gateway or more likely the Ruby gem surrounding the gateway was misparsing. And this last 4 would come in as nil. You know what would happen then? The save would fail and would not come into our database. And we would have an angry customer. And when I realized that that was happening, I went through the code base very, very carefully, inspecting everything that we were doing after the credit card response was received, with the idea that every line of code after that card processes is potentially somebody screaming at me. Like, this is what I needed to think about. Like, what could, and obviously code review always has this aspect of what could go wrong, but there was this intensity that I suddenly brought to these lines of code. Number one, to minimize the amount of processing that we were doing afterward, and number two, to really think about this in terms of a very bad outcome for this client and their customer. And you start to think about, is this validation really necessary? In this case, I think it's clear, it became clear as soon as it started failing, that this was not necessary, that it was not important enough to throw away a live transaction. And this is, I think, an important rule of thumb for any data validation. Like, is this piece of data, is it so important that this data be clean? Is it so time-consuming to clean that data up that it is worth potentially canceling a live transaction that has already taken place? Sometimes the answer might be yes. I think a lot of times the answer is no. The worst thing that happened in this case is that we didn't know what their credit card number was, and since we weren't actually doing anything with that fact anyway, that was fine. I had the really great opportunity to interview Dave Thomas, pragmatic programmer Dave Thomas, about the structure and the things that they did to build the pragmatic app store. And one of the things he said was, if it is at all possible, always screw up in favor of the customer. So write your code in such a way that you bias towards the possibility of the charge failing but the code succeeding rather than the charge succeeding and the code failing. And there are a couple of things that you can do in your application design that can help, and as you're building the application, that can help. Very secretly, a lot of these problems are actually like solved by good software design rather than any magic about dealing with finance, although there's a little bit of that. One of the most important things you can do is test for failure conditions. Not just TDD. TDD is great. I love TDD. I write about TDD all the time. TDD is not necessarily enough to be a full validation against a payment gateway. And you really want to make sure that you test that your application behaves robustly in failure conditions. It actually turns out that this is easier than you might think. Testing for credit card failures is actually fairly easy in an integration test standpoint, depending on the gateway you're using. Most of the gateways provide a really rich set of test data that will automatically trigger a failure condition. So you put in this credit card number, and it automatically says unfunded. Or you put in this address, and it automatically says fraudulent. And then you can choose to respond to that however you want. That's really valuable. Even just the one case of this credit card was denied is really great. It doesn't necessarily help you get against networking failures, but you can do that with stubs and application design. So testing for local failures, either the network problem or your database failure, that's a little bit harder against the complexity of your application. I really recommend in this case, one of the advantages of having a good encapsulated design where all of your interaction with the gateway goes through a particular single object, or all of your interaction with the database in a particular time goes through a particular object. One of the advantages of that is it's very easy to stub that interaction with a test double or a mock object to simulate failures, which, again, is really helpful in dealing with this. I should say that to some extent, some of these things are lessons that I learned while applying it. Not all of these things actually found their way back. Not all of these pieces of good advice found their way back into the live application because of legacy code and time and budget issues. They found their way into other applications that I've written. And other things that I think are really, turn out to be really important. One specific kind of database validation is a foreign key constraint. These are potentially really valuable in making sure your data is clean. They're very annoying when you're trying to test, especially when you're trying to unit test, because they require you to create a lot more objects, usually than you want to, because you have to have a real object on the other side of a foreign key. That said, this is the kind of validation that is sometimes really helpful, especially if your database has a lot of small tables. That's often a validation that's worth keeping around. Another way to deal with the effects of failure is to break up these applications, break up your workflow into a series of small background jobs. So for instance, you might have when the user submits their credit card request, you might actually do some processing and then submit a background job that actually does the credit card piece, and then another background job that does the mailer. Or you might even have the user response actually triggers nothing but a background job. So you have one background job that does the setup, another background job that does the actual credit card processing, and another background job that reports success or failure. There are a couple of advantages to that. One of which is that it relieves you to some extent of the need to do certain kinds of error checking, because later jobs only get triggered if earlier jobs succeed. So you don't have to continually check to see if you're in a good state, at least in theory. It also limits the consequences of failure. If the credit card transaction part of it fails, the setup part of it still exists, and it exists in a state where you can rerun it later after you've addressed the failure point. And that's also really valuable. There's also this concept of idempotence or idempotence, depending on how you pronounce it and who taught you how to say it, which is a computer sciencey concept where about a process that returns the same result no matter how many times you run it over and over again. This is super valuable in a financial context. If you accidentally trigger a payment twice, you don't want to actually trigger a second credit card transaction, or you don't want to, certain cases, your business logic should only be run once to calculate a price or something like that. And if it runs twice, you want to make sure that it returns the same value over and over again. So this is also something to test for, to test what happens if you write a test to see what happens if you call a process twice to make sure that you get the expected number of outcomes. One thing that is also true is that there are a lot more things that can cause issues in your financial application than there are actual ways that those things manifest. Like the number of footprints is a lot smaller than the number of things that can cause footprints, if that makes sense. And it is sometimes easier to see the result. We have a double purchase, we have a miscalculation, than it is to find the cause. And depending on your own time and budget constraints, it is sometimes easier and more valuable in the long term. I don't recommend this as a general strategy, but it's something to keep in mind, that it is sometimes easier to mitigate and be able to notice and fix a failure case than it is to actually find what caused it. Again, I'm not submitting that in the general case, but like potentially my application has something that happens maybe once or twice a year under strange circumstances that we can't figure out. It would cost me like a day or two to figure it out. It costs me 5 minutes to fix it once it happens because I notice it. We notice it quickly. It takes a lot of 5 minutes to add up to a day or two. So that's something to keep in mind in terms of return of investment. Another thing about money that is different from a lot of other data that you deal with, money is very precise. People get mad about very small differences in money than what they're expecting. And money is actually so precise that it kind of breaks math. Specifically, it breaks floating point math. Money is more precise than floating point numbers. If you were like me and you were a kid that had a calculator and liked to hit the square root key a bunch of times and then hit the square key back up and see that you didn't get the same number back, that's the kind of thing that I'm talking about. You have these sort of persistent rounding errors. And you can actually get these in Ruby surprisingly quickly. This is an IRB session. I actually did this morning. I don't know why it's 224 and not 231, but that's not really the issue here. 3.01 times 5 gives me 15.049 repeating, which I'm pretty sure would not be correct in math, in my math class. And this is a problem in a couple of ways. I mean, it's obviously a very, very small difference, but at volume, these differences tend to add up, and they're a little bit unpredictable. And the slightly more insidious form of this is that 15.0499 does not Boolean equal 15.05. So if you have code that depends on two floating point values being equal, you've probably seen this in other contexts. That's a very fragile test. In Ruby, I recommend we have the money gem, which integrates really nicely with Rails, stores money as a Ruby big decimal. Without getting too much into the internals here, big decimal is not quite an integer, but it is an exact representation of math to a particular number of decimal points. So for instance, I can say, I can create a new big decimal at 3.01 to 3 digits of precision, multiplied by 5, and then I do get 15.05, as I expect. The other interesting thing here is that if you went to an American elementary school, you were probably taught to round numbers in such a way that when you hit the halfway between point, you always round up. I think that's what I was taught. That's not actually what banks do. It turns out banks actually round to the even number. And the reason they do that, I believe, is so that in a long series of numbers, if you only round up over a long series, the rounded sum will tend to diverge from the unrounded sum. But if you round to the even number, the rounding will tend to go in both directions, and they will tend to stay the same, more or less. So in any case, none of that really matters. The relevant point is I thought it was cool. And the other point is that the money gem actually lets you specify the algorithm that you use to round when you hit the middle point, and there's like 12 of them, which was like it was like they'd invented a new vegetable that I didn't know about. It was like amazing. Money also requires record keeping, and not always necessarily in the way that you expect. In this application that I'm dealing with, this actually came up really recently, so I can't even blame it on my own naivete. They have a handling fee of a certain kind. It's flat. It's a flat fee. And I thought, I don't need to put this flat fee in the database for every single transaction. I'm a computer person. We don't like to waste space like that. I will treat this flat fee the way it deserves as a constant. So there was a constant in the application, handling fee 200 cents. We're storing stuff as integers. Works great. Some of you may know where this is going because you have worked with clients before. The client said basically, hey, we like money. Let's raise the handling fee to $2.50. And so I did, and I changed the constant, and it worked great. Everything worked, we're done, except for one thing. all the calculations historically that were in my database, all of those payment calculations, I could no longer recreate them because the data that was used to calculate them was gone. And I actually wound up having to put in the code base, like if this payment was happened before this date, the handling fee is $2, and if the payment these are not the actual numbers or the actual date, you get the point. So this is a problem. Like you actually have this need to be able to recreate not just the payment potentially, but the pieces of that payment, to recreate shipping fees, definitely to recreate taxes. If you are dealing with taxes, you need to be able to recreate that. So you really need to actually store all of those things at the time of purchase. Store the date too. Don't depend on the created at date that comes from Rails. Your goal here is you should be able to recreate the entire purchase even if the logic has changed, because it is not feasible to keep perfect historical logic forward in all cases. Your shipping fees may change, the tax laws will change, processing fees will change, that kind of stuff. So you need to have something. The good practice here is to actually, when you store your transaction in the database, to store all of these individual line items as they were calculated. I also recommend, and again, this is like some of this stuff is honored in the breach rather than in the practice. I recommend keeping a record of failure when failure happens. So making sure that your application works in such a way that you don't completely roll back a failed transaction, but that you store it in a failed state so that you can, number one, know that it happened, diagnose, potentially rerun. That's valuable. I mean, that goes beyond things like notifiers like rollbar or something like that tell you what happened, when an error happens. Also, really helpful to have some sort of audit tool. Paper Trail is a Ruby gem, a Rails gem that does it, a Ruby gem that does this. Paper Trail sits on your Rails application, and when an active record saves, it stores the previous version of it in a different database table so that you can go, and also stores who made the change so that you can go back and look at that information. This is potentially pretty valuable in a situation, especially in a situation where you're a little bit paranoid about your administrative users or something like that. I also recommend doing kind of a meta validation of your data. We have a script that runs nightly, and it validates that all of our inventories match what we think our inventories are. It validates that we charged all the users that day what we thought we charged them, to the extent that we have that data. And it does a couple of other checks on top of that. This has saved us from bugs in the past that were not found otherwise. We had inventory, like an inventory management issue. And it's a really good thing to be able to do, be able to make sure that you can validate if your application gets into a weird state. Money also has legal obligations. And in practice, one of the things that means for you as an application developer is you need to take your administrative users seriously. Many of us, I'm sure, have at some point or other said something like, oh, they're the admin users, we train them, they can put up with anything. If you haven't, congratulations. That's a problem. Administration users are potentially very valuable to this kind of application. Again, one of the things that came out of this interview with Dave Thomas was that the administrative code in Pragmatic's application is twice the size of the main application, just the behind-the-scenes stuff that users don't see. And one of the reasons for that, there's a couple of reasons for that having to do with their logistics and things like that users don't care about. But another reason for that is that administrators can change rules. Like if somebody comes to me and says, hey, we've got a really big customer and we agreed to give them a 10% discount because they're a really big customer, like for me to turn around and say, I'm sorry, there's no way the database can't do that, that's not going to fly. Like there needs to be a way, there's this tension between the need to keep the application in a valid state and the need to make these special cases when special cases come up for the good of the business. A really quick example here is refunding, which is something you need to add once you start taking payments, because people will occasionally ask for refunds for any reason at all or no reason at all. And refunds are also a one-line API call, and in some ways they're even easier than charges because they're already authenticated. But they lead to a whole host of application-level issues. Who can authorize one? Can you do partial refunds? How do you manage the response? How do you track inventory? How do you track changes to revenue in your reporting, and so on and so forth? And all of these issues are really hard to deal with, and you really need to think about how to think them through in a way that these things can happen easily. You also want to take reporting seriously. This was a real problem in this particular application. I thought, I know how to do reporting. It's just like an index page. We just do a select all and just throw it on the page. Turns out that's insufficient and really slow. Reporting is important for a couple of reasons. It's how the business users of your application make decisions. They see trends and things like that. It is also your input to financial compliance, taxes, accounting, and the law are the data that you can output. So you want to look at things like, again, background jobs, potentially having a separate database, a replica database that only lives to handle reporting, potentially pre-generating, pre-calculating some of the subtotals and complicated reports on an hourly or a daily basis to limit the load on the database, that kind of thing. Money's also really private. And it's really important that you don't store personal information that you don't need. You probably all know this, but it's really important. Don't store credit card info at all. You do not want to deal with the hassles of being compliant enough to store credit card info unless you are extremely large. And even in that case, you still have issues because you need to make a strong distinction between the servers that touch credit card info and the servers that don't. Most of the gateways have a mechanism by which you can authenticate credit cards from the browser through JavaScript and send a one-time use token so that you don't ever see credit card or personally identifiable information. Strongly recommend that you use those where you can. Even information that seems boring to us can be harmful in the wrong hands. Address information, in some cases even just the identity of your users at all in their financial records, even if you don't have credit card information to go along with that, is stuff that you don't want to get taken away. And I don't have like a silver bullet here for that. Just something that you really need to be aware of as you're building your data models. Okay, I'm almost out of time. I have a couple of things to take away from this talk. One, again, the API is the easy part when you're dealing with financial stuff. It's the stuff around it, the business flow, the logic, that becomes really complicated. If possible, run your workflows in small steps so that you can manage failure points. Store all your work, but store as little personal user info as you can. There's a little bit of a tension there. Administrative users are important. In the long term, the health of your project or your system is going to really depend on how quickly your administrative users can respond to data changes. And that's pretty much all I have. My name is Noel Rappin. You can follow me on Twitter at Noel Rapp. If you thought this was interesting and you wanted to read like 300 pages of it in ebook or dead tree format, hey, great news for you. You can do that. It's available. It's a book called Take My Money, Accepting Payments on the Web. I absolutely adore this cover. I think it's fantastic. You can get it at pragprog.com/book/nrwebpay. And the last one got cut off. You can find me in general at noelrappin.com, where you can get a couple of other things that I do, including a book on projects called Trust-Driven Development, and you can link to Rails Test Prescriptions, a book I wrote on Rails testing. I will be around for both of those days if people have questions. I have like 1 minute for a quick question if somebody's got it. Otherwise, thank you very much for your time, and I'll see you around for the next couple of days.